Welcome. In this video, we'll be calculating the second order derivatives of a function. I promise you this video should be rather short and simple. Okay, so first of all, you could have a go at this example question if you want. I usually give my students a starter, that's why this question appearing here is not part of the teaching here, but if you substitute each coordinate into that equation there, you get three equations and you can solve them simultaneously. If you wish to have a go, pause the video and have a go at it. Otherwise, the final answer will be value of a equals to 1, b should be 2, and c should be minus 3. So let's get to the meat of the problem here. We're going to find the second order derivative. Okay, so what does that mean? That means that we are going to differentiate the derivative function. So the second order derivative have this kind of a notation, fancy notation, d square y over dx square. Another way, this is equivalent to f dash f double dash of x. Alright, what is that? That means go ahead and differentiate f dash. Alright, so by the way, when you write d and we open a bracket, and on purpose I'm not writing a y here, I'm writing and here f dash, we are differentiating this f dash with respect to x, you're going to get f double dash. Why am I writing d? It's f with a double dash on that side, like so. Okay, f double dash x, like so. Alright, so what do is we simply differentiate this function from scratch. So we are going to, let me change this to pen rather than highlighter. So we are going to first of all write what is dy by dx. It's 15x to the power of 4, and if I had written this carefully I would have read it as 4x to the power of minus 2. So it's minus 8x to the power of minus 3. So this is the first derivative, okay? You could call this the first order derivative. Now, the second order means that you're differentiating the line above with respect to x. You're just going to apply the power rule as normal. 4 times 15 is 60, x will get a power of 3, and minus 3 times minus 8 is a positive 24, and x will be a minus x to the power minus 4. This is basically it. That is the second order derivative. Okay, so if they ask you what to do, that's what you will be doing. Alright, so apologies about my writing. You see, these uh, exactly match. Right? So that is how you do that. So next, look at another example. First of all, let's rewrite the original f of x with explicit powers of x being a half here and writing 1 over 2 times x power of minus 1. So f dash of x, or the first order derivative of x, is 3 over 2 x to the power of a minus half, and we will get minus a half. That minus 1 simply comes at the front and we'll get x to the power minus 2. This is the first order derivative. We will ask to figure out both of them. We cannot find the second order without finding the first order derivative anyway. So it's a moot point to say find f dash if we have to find f double dash. So there is negative half times 3 over 2, so we will have a negative 3 over 4, and the new power of x will be minus 3 over 2. This minus becomes a plus because of the minus signs there, and we'll have a 1 in front as a coefficient. New power of x will be minus 3. Notice a half times the 2, so there is This missing, if you don't know what's going on, is a minus half times a minus 2. This whole business is just a 1. This is not an x, this is multiplication, and it's a 1. So that's that one I'm not bothering to write here. So we're not going to evaluate this at any point. This is it for this exercise. We'll do more things with this f double dash in the next exercise. So just practice a few questions. Make sure you can do this at 2 stages, and I'll show you why is it useful in the next video.